Welcome to MOVIMOT and Field Distributors Basic and Intermediate Training. This is Session 4. As you remember from Session 3, we were in the middle of an easy mode startup and we're just going to pick up where we left off and get that finished. So we're moving into easy mode startup, Part 2. In this part, we're going to set the various dip switches on the MOVIMOT control head. These configure its behavior. You'll need to set a few of these before your MOVIMOT is ready to run. But before we get started, just a little safety reminder, I'm going to say this again, always disconnect power and wait at least 1 full minute before removing the control head. Remember that control head can be charged up and you want to give the capacitors time to discharge, so waiting 1 minute is necessary. It prevents you from getting a serious electric shock. Alright, this is the first set of dip switches we set, and you can see the bank we're going to work with. It's the S1 bank. It's divided into 2 groups and the switches are numbered. We're going to be setting switches 1 through 4 in this step, and then we'll move on and look at 5, 6, 7, and 8 individually. Switches 1 through 4 on bank S1 set the MOVIMOT's address. This is a number that uniquely identifies it. The address you set your MOVIMOT to depends on the mode you're operating it in, so you need to know what you're intending to do with it in order to set the address. If you're going to run it in binary control mode, it's really easy. Just set it to address 0. When you set it to this address, the MOVIMOT knows it's running in binary mode and it won't expect any control coming from anywhere else. On the other hand, if you're going to operate the MOVIMOT either with a field distributor or the set point adjuster or one of the other RS-485 devices that you can connect to it, you'll set it to address 1 because it expects communication on that address. If you're using a PLC or a digital controller that's equipped with an RS-485 interface and you're setting up an RS-485 network with multiple MOVIMOTs on it, then you would set the address anywhere between 1 and 15. Typically on an RS-485 network, every single MOVIMOT would have its own unique address. Again, of course, that's going to depend on your application, what you're doing with it. So those are the different address possibilities that are available, so you'll need to pick one that fits your application and your mode, and then set it accordingly. One little warning here, if you've worked with dip switches and binary numbers before, this may throw you, but the switches are backwards. In other words, the most significant bit is on the right side, not the left side where you usually expect it. So the numbers kind of go backwards from left to right instead of right to left. Just to make this clear, I'm going to show you the patterns that correspond to the numbers from 0 to 15. If you're not too comfortable with binary numbers, you can just look at these patterns and set the switches accordingly to get whatever address you feel is appropriate. Hopefully that made sense. Let's move on to step 5. Now we set the other 4 switches on the S1 bank, switches 5, 6, 7, and 8. These individually enable or disable various features. Tables in the MOVIMOT manual, which I'm showing below, will show you what these switches do and also the default settings. The default settings are boldface. Let's take the first one here as an example. We're going to look at switch number 5. This one controls motor thermal protection. What that means is that if the MOVIMOT is mounted directly on the motor, it can monitor the motor's temperature and shut down if the motor gets too hot. On the other hand, if you're using the Mount Nearby feature where the MOVIMOT is mounted on a plate and connected by a cable to the motor, it can't monitor the motor's temperature directly, so you would disable this feature and use a different method of protecting the motor. Now, this is a little confusing. Look at the table there. By default, we can see that motor protection is turned on because that's the boldface choice. But that's actually the off position of the dip switch. That seems backwards, but it's just what it is. If you're using your MOVIMOT mounted directly on the motor, you would typically leave this feature switched on, and you would do it by switching the dip switch off. If you're mounted on a plate nearby, you would turn this feature off by turning that switch on. Okay, I know that's a little crazy, but that's just how it is. Let's move on. Switch number 6 is kind of an interesting one. It allows you to use a larger MOVIMOT on a smaller motor. Normally, the motor and the MOVIMOT are sized to each other, but it is possible, for example, in a maintenance situation, to take a MOVIMOT from one motor and move it to another. If you have a motor that's a little smaller than the MOVIMOT, in other words, the power rating is different, you can use this feature to make it work. You would turn that switch on and the MOVIMOT would know it's working with a smaller motor and restrict itself. I recommend you look in the MOVIMOT manual to fully understand this because it gives you the guidelines for this kind of a swap. So this is really kind of a maintenance situation perhaps. Switch 7 chooses the pulse width modulation frequency. Remember, the PWM is the way the MOVIMOT generates that synthetic AC that controls the motor. Well, it can turn those IGBTs inside the MOVIMOT on and off at different speeds. Now, if it turns them on at a lower speed, maybe just a few thousand times per second, the MOVIMOT runs cooler. But the disadvantage is many people can actually hear the switching and they find it very annoying. It's kind of a high-pitched whine. By default, as you can see from the table, the MOVIMOT runs the pulse width modulation at 4 kilohertz. That's 4,000 times per second. That is clearly audible to many people. So what a lot of people prefer to do is turn off the default and turn on what's called variable PWM. What the MOVIMOT will do in that case is try to use 16 kilohertz instead of 4 kilohertz. That is not audible to most people. Your dog and your cat could probably hear it, and if you've got really good ears, maybe you can hear it, but most people can't. What it will do, however, if it's running too warm, is it will start switching down to lower frequencies to cool itself off. It'll switch to 8 kilohertz and then 4. But it will try to run at 16, and as long as it's not getting too warm, it'll continue at that and it'll be quieter. Switch 8 controls what's called the resonance reduction feature. In certain situations, if the motor isn't loaded, it can resonate, which will cause it to vibrate. If you activate this feature by turning the switch on, notice it's off by default, it will try to control that sort of resonance and prevent it from happening. Again, this is a special situation that you would only activate if you needed it. All right, that takes care of the first dip switch bank, so let's continue. Switch bank number 2 has 4 switches that control additional features. We'll cover these individually here. The first switch selects the brake type. When it is switched off, which is the default position, the MOVIMOT will expect a standard brake that is properly sized to the motor. On the other hand, if you turn it on, you can use different alternative brake sizes. You may have to do this in a specialized situation. To see what brakes are involved, you'll have to look in the MOVIMOT manual. It lists the different sizes and tells you which position of the switch is appropriate for given brakes. Of course, if you're not using a brake at all, it really doesn't matter what this switch does, and you should probably just leave it in the off position. Switch 2 controls the brake's behavior if your motor has one. The default behavior is that the brake will not release unless the MOVIMOT is enabling the motor. However, there are situations where you want to be able to release the brake without the motor being enabled, and if you need that feature, you would turn this on by switching the switch on. Normally, however, it's undesirable for the brake to release without enable, so you'd leave this in the off position. Switch 3 controls how the VFD generates the synthetic AC. There are 2 modes, VFC and VF. VF is a more primitive basic mode. Really, the only reason you might use it is if you're trying to control an unusual motor that doesn't work with VFC. But if you're using an SEW Eurodrive motor that's properly sized to the MOVIMOT, use VFC, you'll get more accurate speed control and better performance. So you can see that's the default option. And then finally, switch 4 selects what's called speed monitoring. This is turned off by default, but if you switch it on, the MOVIMOT will monitor the current that the motor's drawing. And what happens is if the shaft gets locked or jammed, the current will skyrocket. The MOVIMOT will detect that, realize the motor isn't turning, so in other words, the speed is not what it's supposed to be, and it will shut down to protect itself. So this is a protective feature. It's off by default, but many people will choose to turn it on. And that takes care of the second bank of switches. And then finally, we have a third bank of switches. This is actually an extension of the S2 switches, even though they're in another location. There are 4 more positions here. And what this does, it modifies the standard behavior of the MOVIMOT. Again, the switches are backwards, so when you look in the MOVIMOT manual, they'll give you the decimal number of each feature, and if you tried to convert that to binary, the binary number would be backwards relative to what it is here. So again, remember the least significant bit is on the left side, which is a little strange. Now, these are the possibilities that are available here. If you set the switches to all zeros, you will just get default basic functionality. Most people leave the switches in the 0 position because the alternate positions activate features that are only used in specialized situations. I'm not going to go through these individually. You can go to the manual and read about them if you think they might apply to your situation, but I am going to talk about just 2 of them to give you an idea of how they work, and these 2 actually you might use sometimes. I'm going to look at these 2. Option 1000 and option 0110. So let's take a look at those. This is called option 1. You set the switches to 1000. Remember, the switches are backwards relative to normal binary positioning. What this does, it increases the available ramp times. In our last session, we looked at how you set the T1 dial to pick the ramp times. You may have noticed most of those ramp values were fairly short, no more than a few seconds. What if you need a really long ramp? Well, if you do, you can activate this feature by picking this switch pattern and you'll get longer ramp times. What will happen is ramp settings 0 through 5 on the dial remain the same, but 6 through 10 are increased. So this is the chart of standard ramps. You notice at 0 through 5, the ramp times range from 0.1 second up to 1 second, and 6 through 10 go from 2 to 10 seconds. If you activate the extended ramp times, here's what happens. 0 through 5 stay the same, but 6 through 10 become 20, 25, 30, 35, and 40. So you get these really long ramps. So if for some reason you need to have a really slow acceleration or deceleration, activate the extended ramp time and you'll be able to access these. All right, so that's our first option. The other one I'm going to look at is option 6. It's called the modified PWM feature, and you set your switches to 0110. What this does is it allows you to have an alternative automatic PWM. If you activate variable PWM or automatic PWM, normally the VFD will choose 16 kilohertz and only downshift to 8 or 4 if it gets too warm. If you activate this feature, it will not use 16, it will only use 8 and 4. You might do this if you feel the VFD tends to get a little too warm. You want it to operate at the lower PWM frequencies instead. Of course, if you think it's going to really have a problem, you probably just pick fixed 4 kilohertz and put up with the noise. Okay? Let me point something out that you may not have noticed. Underneath the control head is a handy little cheat sheet. It doesn't contain all the information you need, but it contains a lot of it. For example, you can see it lists the F2 dial frequencies and the T1 dial times. It also shows a diagram of the dip switch banks and identifies what each switch does. The only thing that isn't there is the F1 frequency graph and also that table of choices for alternative operations that the S2.5 through S2.8 switches control. There just wasn't room for those, so no way those could have been fit in. But anyway, this can be a real help to you and might prevent you from having to dig into the manual. At this point, you have the control head properly configured, but before you put it in place and torque down the bolts, you probably want to do a little wiring inside to get the MOVIMOT ready to be controlled. So I want to talk about the low voltage wiring here. How do we wire it up for binary mode? Well, it's super simple. You do it this way. All the control signals must be 24 volt. You can use just simple switches, and I'm showing you a diagram here for that. You would connect the 24 volt power supply to one side of the switch, and you would connect the other side to the clockwise digital input, the counterclockwise, and the F1, F2 input. These switches will then allow you to control the motor in both clockwise and counterclockwise direction and select between the F1 and F2 set point speeds. So you would do that. If you were using a PLC or something with contacts, you would need to wire it up in a comparable way. Just remember, don't put more than 24 volts onto these inputs. Now, the second thing you can do is wire up the relay. You can do this if you want to use it as a status indicator. It closes when the MOVIMOT's ready to run and opens when it's not ready. And what I've done here in my diagram is shown it connected up to a light. So what you would do is you would connect 24 volts to one contact, and then you would connect the light to the other and then ground it. Of course, the light would have to be 24 volt compatible. Many indicators in industrial control equipment do meet this requirement, so everything would be just fine. Remember, this is a low voltage relay contact. Do not connect it to 120 volts AC or anything high like that because you will damage it. It's meant for low voltage DC. Instead of connecting this up to a light or other indicator, you could use it as a simple digital output to drive the digital input of a PLC or other controller. Just connect it up in this way to a 24 volt supply and then feed it directly into the digital input. That way the device can monitor the status of the MOVIMOT, whether it's ready to run or not. Of course, if the input on the device requires a different voltage, like 5 volts for example, then you would need to wire it up to a suitable power supply. There are a lot of possibilities, but the relay is a handy thing to have. If you don't need a feature, just don't connect it. For example, if you're not going to run the motor both directions, you don't have to wire up both switches. If you don't need both speeds, you don't have to wire that up. And if you don't need the light, of course, you don't have to wire that up. It's fully within your control. I'm just going to mention how you wire up for RS-485 control since it is very similar, and you can use the easy mode startup for RS-485 control as well. The difference is you wouldn't use switches. Instead, you would just use jumper wires. And what you would do, you would connect 24 volts to the clockwise and counterclockwise inputs. You would leave the F1 and F2 disconnected, and optionally you could wire up an indicator of some kind on the relay. Now what this will enable the MOVIMOT to do is run in either direction under RS-485 command. If you don't need it to run in both directions, in other words unidirectional operation, then disconnect whichever direction you don't need. So normally you enable clockwise and counterclockwise by connecting them to 24 volts, but if you're just running one direction, just wire up that one and leave the other disconnected. Pretty simple. All right, time for a hands-on. I'm going to give you a set of instructions, and then if you wish and you have your own demo unit, you can go and do it, and then I will demonstrate how I do it with mine. So here are the instructions. You've already set the dials on the control head. You just have to set the S1 and the S2 dip switches. And so here's what I want you to do. I want you to configure them for binary control mode. I want you to activate motor thermal protection, assuming your MOVIMOT is mounted on your motor. Of course, if it isn't, then you shouldn't activate this feature. You should select a normal motor size, select variable PWM, and I'm going to say just use the standard 16 kilohertz variable PWM. Disable no load dampening, select the standard brake, select the brake release only on motor enable, choose VFC mode, activate the speed monitoring feature that prevents overcurrent, and select standard behavior. All right, go ahead and pause the video and do it, and then come back and you can watch how I did it and make sure you did it right. And if you don't have a demo unit, of course you can watch me do it and see how it works. All right, time for a demonstration. I will show you what you have to do to meet those instructions requirements. So here are the instructions that we need to do. So let's just go through this one by one. How do we configure for binary control mode? We set the address to 0. So the address switches have to be all zeros, so they would be turned off. Next, we activate motor thermal protection. So we have our little chart of options. Motor thermal protection right here needs to be activated, so that means the switch has to be off. So we'd leave that switch off. That's its normal default position. We need a normal motor size, so we would leave the switch off for that one as well. We want variable PWM, however, so we go from the default position of off to on, and we don't need the no load damping feature, so we leave that off as well. These switches should be 0010. Now we move on here. We're going to use a standard brake, so we leave the switch off. We don't want the brake to release unless the motor is enabled by the VFD, so we'll leave this switch off. We want VFC mode, voltage flux control, which gives better control, so we'll leave the switch off for that as well. But we do want speed monitoring, so we're going to turn that switch on. Therefore, we're going to set these switches to 0001. All right, almost done. We have to set the other half of the S2 bank. That one configures the alternative behaviors, but we don't want the alternative behaviors. We just want basic functionality. So we just set those switches to all zeros, and we're good to go. Let me just mention that when you're setting dip switches, it's a good idea to use a metal tool like a small flat-bladed screwdriver to set the switches. Don't use a pencil because the graphite is conductive. It can work its way into the switches and cause shorts. Some people use a ballpoint pen, although that gets ink all over things, and you can see someone's done that on this MOVIMOT because there are ink marks on it. These switches are set correctly. Notice that switch 7 and switch 4 are both turned on. All the others are turned off, and that meets the requirements. While my control head's off, I would need to wire up my control switches and lights if I need them. My demo unit is pre-wired, and so let me just show you how it's set up so I can demonstrate it. This is my control box. It's got a number of switches and indicators on it, and here's how it's wired up. The DI01 switch is clockwise, DI02 is connected to the counterclockwise input, DI03 is connected to the F1, F2 input. So by manipulating these three switches, I can control my MOVIMOT's direction and speed. And also the D002 light is wired up to the relay in 24 volts. Of course, at this point now I need to put my control head back on. I need to tighten the 4 bolts to the correct torque value. Remember, you should always replace your gasket if the MOVIMOT's been closed up for a while because it does develop a memory. It won't maintain its IP rating without a fresh gasket. Of course, with a demo unit, we don't care. We're running in a clean environment, but that's a useful reminder that you should always bear in mind. The plug covering the F1 dial should also be closed and torqued to the correct value. Let's go to my demo unit now, and I'm going to see if I can run it in 2 directions and at those 2 speeds. So here we go. All right, notice that the status light just turned on. That means the drive is ready. So I'm going to try running it clockwise at my F1 speed, which is 1200 RPM, and that seems to work. Notice it is taking about 3 seconds to speed up and slow down. Here's counterclockwise, running the opposite direction. Seems to work fine. Again, 3-second ramp. Now we'll switch to the F2 speed, which is 300 RPM, and you can see we're definitely running at a much lower speed. Runs fine in clockwise, and runs fine in counterclockwise. So it looks like everything is working correctly here. MOVIMOT is easy. All right, well that is the end of session 4, and that is the end of Easy Mode Startup. You can see that you can get your MOVIMOT running quite easily in just a few minutes. When we move on to session 5, we're going to look at a few other things that you need to know about your MOVIMOT, like how to tell if an error occurs, what kind of error is happening, and we're going to take a quick look at the DBG60 keypad and see some of the things you can do with that. So, see you then.